Hello friends, I wanted to explain some of my pixel expressions that I've uploaded to the Logic portal. I'm going to go from simple to a little more complicated, and I'm going to go fast because a lot of them are self-explanatory. First I have some different noise setups. So Voronoi, a couple of different patterns. Here's a cell pattern. All of these have variables that you can adjust. One more Voronoi noise. Pattern generators. These are simple two-color patterns. Most of them have different scaling options. What you see is white and black. You can change RGB values for each of those, so you could do different colors. Here's a checkerboard. Here is a hex grid, a spiral. This guy, you can change the number of arms. You want to do whole values, or else you get like a little split line. A moire pattern, if you need to actually generate some moire. A point grid. This can be nice little dots, or it could be big circles. Here's a lattice where you have rounded boxes. Here's a star field. Hopefully you can see this. I'm going to play, and there's a twinkle factor. So all of the little dots twinkle, and I feel like it's a decent star field. A triangle pattern. Here's a Truchet pattern. You can change the thickness of the lines there. This is just an interesting wave interference where two waves cross each other. And then one more kind of wave, but this is a zone plate. The next category is shapes. We've got standard shapes, square that you can do, make hollow. You can change rectangle size. You can soften it. Same thing with the circle. Polygon from 3 sides on up. That can be hollow. You got rotation, got the softness. Here's a ring, radius, thickness, softness. A rounded box. So this is nice because it keeps the rounding proportional no matter the size you do, and you can change that rounding, the corner, however much you want. Softness, hollow, same thing. Two more little things just to kind of see what you can do is this metaballs. As they get closer together, they start to attract each other, and those 3 different balls you can move all around. Same thing with this ring of metaballs, they start to clump together. Next I've got some animated generators. So again, just patterns, but animating the channels can give you some different results. There's like a ring ripple. Here's a spiral that turns. These vertical patterns, you can change the size and the position. These are all just variations on that with different fall-offs: parabolic, sawtooth, sine, square, and triangle. Next, some cool, awesome filter effects. So here's my original image, and we've got a dither, and you can set the levels for that, how many levels of dithering you got. Similar is crosshatch. We can change spacing, line thickness. I've got this CRT, like little diodes, and on this one I also added a highlight roll like you might get on like a VHS tracking whatever, and halftone with circular cells. So you can adjust those. It's all pretty quick. So the idea with pixel expression is you're doing GLSL math with the GPU. Everything renders extremely fast, faster than probably some nodes in Flame that you can do the same thing with that are standard, but hopefully this is faster, and this is all exposed to Python. Next category, diagnostics. So I've purposefully clamped my image, shadows, and highlights. This clip highlighter just gives you where highlights are clipped. Zebra gives you where shadows and highlights are clipped. Gamut clip, the yellow, the gamut is out of range. False color is similar to like an exposure on an ARRI camera, where cooler colors are less exposed, hotter colors are more exposed. You could use that for a cool effect aside from just a diagnostic. Zone system, this is an Ansel Adams photography concept where you have zones of exposure, so you can go from 2 up to 10 or more zones, and it clumps everything together in a zone of exposure. Similar to that is contour exposure, so it shows you the contour lines separating different exposure levels. And then color blindness. This simulates the 3 different color blindness types that are out there in some people. So there's 0, 1, and 2, 3 different types of color blindness. I've tested this with someone that is colorblind. I was doing before, after. He couldn't tell the difference, so I think it works. Next category, utilities. Sometimes in your CG renders, you might get a nan pixel. This just clamps nans down to 0. This is a UV test chart. So a quick way to just grab kind of a grid in case you need to see what's going on in your 3D scene, how the textures are wrapping. This is a very simple, just an ST map, flat, nothing to it if you just need to quickly get a ST map. Let's see, that's all of the diagnostics and utilities. The next thing is, again, stuff you can do already in Flame, but maybe this is quicker, and you can save these setups as presets. So like you can quickly get to, I've already used this Alpha Crunch. So anyway, the matte tools, this one clamps softness down, Alpha Crunch. This is just edge, anywhere that's softness and not 0 or 1 in the matte. Alpha Fill, any softness becomes completely white. This is a quick little garbage mask, and all I really need is just a quick little line like this. You can rotate if you need to, and offset and feather. So that's a quick way just to get a straight edge mapped. And then a matte tool for a Luma key. Again, you can already do this in Flame. Maybe this is faster. You can set the low and the high for Luma clamping. That is matte tools. Next, color grade. So these tools are for coloring, grading. I've got this simple blue despill. I've got the same thing for green. This is a highlight desaturator, so if your highlights are showing a lot of color through, there's softness and threshold. Here's a simple vignette. That's adjustable down, and the softness of it. Let's see, saturation by Luma. So this is a kind of a split tone. You can desaturate shadows or desaturate highlights separately within this one node. Voxelize is a kind of a posterize. You give it a number of colors that you want, and it clamps colors down to just that amount of colors. And a simple white balance. Let me reset it. If we are at 100, we're just moving the red, green, and blue channels. One more color thing. So this is a It's called hue preserving clip. So if you use a color correct node and say this is blown out, this is the front or incoming image, and if we gain down, you see that what was clipped is just pretty much gray. What hue preserve clip does is when you bring the gain down, it tries to maintain some kind of hue or color in what was clipped. Next category, HSV color or HSL. You can kind of do this in Flame already. You could mono hue, mono saturation, mono lightness, do some whatever you want with them, and then recombine them back. What I've got here is one pixel expression node that converts RGB to HSV. So the red channel is hue, the green channel is saturation, the blue channel is lightness. So from here you can do operations in the middle on each of those channels and then convert it back to RGB. So you basically unpack it and then repack it. So with that, we can do stuff like HSV color replace. So say I want to, I'm going to do this extreme so you can see, but the source hue, and this is based on a 360 color wheel. So the source hue is red and I want it to go to green. So it changes the hue without affecting saturation and luminance. HSL targeted is similar. Pick a hue, and then only within that hue you can desaturate. Let me show the result. So we can change the hue of just that hue. It's kind of like hue versus hue. Saturation only in the reds because I've chosen center the hue there, and luminance. Hue rotate, all that does is just swing the whole image around through hue. Split tone is like in the shadows, we can make them cooler, like the shadow hue that's reds. Let's say we want to do, like blues, and then in the highlights, we want the highlights to be kind of yellow. So that's a way to do like a split tone. Vibrance is just like Lightroom, I think, in Photoshop, how it's going to boost lower saturated pixels first over higher saturated pixels. So you're not just shifting everything up in saturation, it's trying to enhance the less saturated pixels. Okay, that's HSV color. Okay, a little bit more complicated now, but interesting. 3D position tools. So I have an action with a 3D scene, and I can move around to show you that. This pixel expression, I'm out of the action, I'm sending position pass and normals. And so with that normals pass, I can get a Fresnel lighting and use this for compositing or matting something. A normal light, so basically a flat front light. If you look at my action setup, the light is coming from behind here. This normal lighting, that gives us the normal. Also, I should show this. If you do like a context, and I go to the action, but I'm looking at the context, I'm going to orbit the camera around, that pixel expression node renders like it's nothing. Normal to facing, and then, okay, here's a few position tools. So this is either could help you find the position of something, or you could use it for an effect. Rays, rings, and then probably the most useful is just a sphere of light in 3D space. So I can move in X, Y, and Z and relight my 3D scene. Okay, that's depth tools. Next, AOV tools. Again, this is all stuff you can do in Flame with Comp Node, with different blending modes. So let me demonstrate, and then maybe that'll explain it better. I have a CG render with various passes, and I can break it down to relight or do compositing, and then combine AOV layers with pixel expression. So like for instance here, I can dial in the ambient occlusion, and then that gets composited in. From there, I'm going to divide out the albedo, and so just the albedo, I can go do something like, make the shadows cooler, make the highlights warmer, and then multiply that back in on top again. After the albedo's on, then I could do something like take the specular highlight and color it. So the speck gets like a little purple to it. Now if you do something where like you take the emissive and you give it a glow, normally in Flame, if you add that back in, so this is with Flame, just a comp node adding, you see that edge that you get where the math isn't exactly right. But if we do that same glow and then use the pixel expression adding the AOV back in, you get a nice smooth line through that emissive glow there. So all of this is a pipeline that's pretty standard to compositing CG images. What you would use pixel expression for is to do it faster with GLSL, and also because all of pixel expression settings and fields and boxes, they're all exposed to Python. So you could set this up with Python and have it go through all your shots, all your setups, and be set up and ready to go. Let's see, I've also got Crypto Picker. So there's a crypto mat, and we can put in the crypto value for different parts to mat out, either a 2 rank or a 4 rank. What is this? Motion vectors. Here's my action with a 3D object just kind of floating around, moving through the scene, and I'm outputting a motion vector. If you look at the motion vector, it's not always clear like what these colors mean, what's going on. So this motion vector visualizer, let's look at the result of that. It gives you a little bit of a clearer kind of, the color is the direction it's moving, and it's not just the like encrypted data. So this is just a way to visualize your motion. Motion normalize, this is a, if you're doing an absolute value and you need a 0 to 1 value, it clamps it down for you. One more AOV thing. You may get motion vector pass that has noise in it, but when you're just looking at the motion vector, you don't really see it because the data is less than 1 or less than 0. So with the motion vector visualize, if there is any kind of like bad data or noise, you'll be able to see it right away. Okay, depth tools. So once you have a depth mat, a few different things I've got here. So fade is based on the depth, it will darken, and this needs to be between 1 and 0. So it's a little sensitive on the controls. You can't really drag it. So the further back here is getting darker. Same thing with fog. So it's basically just a tint, and you can do RGB value for the tint that you're dialing in the background. Depth grade is basically, you can set a near and a far, and then you can gain up or down the near and the far. So here the far is getting darker and the near is getting lighter. Depth mat is just you can slice your depth mat, pick a specific depth and slice just that depth to get a mat. Depth normalize, if you've got it, out of a 0 to 1 range, it'll normalize it 0 to 1. Posterize is like the slicing of depth mat, but it gives you levels or steps, so you can step through various depths at different gray levels. And then this is kind of experimental. I'm playing around with this, being able to put an object in 3D space. So I've got this action that's just a 3D cube, and it has a depth. this. Okay, and then the depth and the front from our other image is placing that object in 3D space. This is kind of rough. I'm still playing around with this one. Okay, a little bit more with depth. What we can do with a circle of confusion from the depth. I've got a CG scene, there's a depth pass, and this COC from depth. It is analyzing the depth and creating a focus point, and then what we can use with that is we can drive a blur that has a strength input, so like the Y blurs Matchbox. And what I'm doing, I'm animating the focus depth, and you'll see that near and far is going from front to back. That is then the strength of the blur in the Y blur. So hopefully you can see we're getting like a rack focus kind of effect from near to far. And then same thing with the thin lens COC. This simulates camera settings. So you've got a focal length, an f-stop, and a focal distance like you would on a camera. And right here I'm animating the f-stop, right? So it's the aperture getting tighter. And if we look at the result of the blur, it's going from shallow depth of field to a wider depth of field of what's in focus by manipulating the f-stop. Okay, next category. ST map generators. This is just a bunch of kind of basic ST maps. Unsqueeze is a 2-to-1 anamorphic unsqueezer. So all of these ST maps, the main thing you'll be doing is putting them into Flame's ST map node. So you got an anamorphic that's squeezed, it unsqueezes. Polar to Cartesian, it just creates a polar map. Glitch blocks, this is just a fun little if you change this corruption, so we start at 0, it's just a plain ST map. Corruption starts breaking it into boxes, and then if we look at that in the ST map, let's do context 5 and change that corruption. So we'll start at 0, and as we add corruption, it's tiles that move around. Heat haze. This is just, you don't really see it in the ST map, but if you pipe it into a result, you can do a heat haze. Kaleidoscope, set context 6 for that, and do segments. So this is context 6, number of segments to create a kaleidoscope effect, and you can rotate that. Lens distort is just a standard barrel undistorting. A UV transform is just a simple zoom, pan, X and Y pan. Chromatic aberration, just like every other chromatic aberration tool. Okay, the next category is what I call experimental. Suppose you have up to 4 different mats or alphas or data for that matter. You can pipe those into a pixel expression, and it's called channel pack. So you can take those 4 one channel things, pack them into a pixel expression, and then unpack them later further down in your pipe. So maybe just a way to clean up your nodes with lines and everything. Dual output depth. This is similar to the other depth tools, but what I'm trying to do is have a near and a far, and then tint with strength. Play around with that if you want. And then finally, in experimental, this is an idea. It's a little more cumbersome than it's worth right now, just because of the way paint nodes work. But what I'm doing is I've got a paint node for each of exposure, hue, and saturation. Those get combined into an RGB channel that is driving the pixel expression. So what this the thought with this was if you want to really just paint and dial in an exposure, a hue, or a saturation, you'd be able to paint that exposure on. Let's see if I can demonstrate this. If I look at my paint node, and what we want to first do is wipe the paint node with neutral gray, because when we paint white, it's going to increase the exposure, hue, or saturation, and when we paint black, it's going to decrease. So we're starting at 0.5, and then we're going to either add or subtract. Let me do this so we can kind of see. So this is my paint node, but I'm looking at it in context of, if I'm just looking at the result of the paint node, it's a pure gray, which isn't super easy to paint on. So I'm blending it with a context so I can see where things are. So exposure, I'm going to paint white, and because of the way the paint node works, you can't look at the context while you're painting, so that's why this tool is a little rough. But where I painted is gaining the exposure. If I paint with black, it brings down the exposure. And then the same thing with hue. If I'm painting with black in the hue, it shifts it on the color wheel clockwise. If I paint with white, and it doesn't have to be pure white, like I could paint with a little bit lighter gray than the neutral, and it'll not shift as much. If you wanted a very, very subtle hue shift, you would paint with barely a gray. And then the same thing with saturation. If I paint white, it's going to get more saturated. If I paint with black, it's going to get less saturated, so we get like all the way to black and white. Anyway, this is something I was just playing around with, an idea. I don't know how practical it is right now. And that's all of the experimental category. One more, just for fun. I've created a digital counter. So all this does is give you a digital number, and you plug in a number up to 9. 0 to 9, you could do some Python to set up a analog counter display. Radar sweep, this was just to see the capabilities of this, but there's a radar sweep. You can change the, animate the sweep of it, change the decay of the line, and the rings, how thick they are frequency-wise. And finally, I've created just a few Mandelbrot fractals, just as a test to see how the GLSL shader works. You can just kind of play around with those for fun to look at. And that is everything. So check them out, have fun. All right, that's it. Thank you.